don't know the Breakfast Club, then you don't understand what we're talking about. This is from 8.4. That's a highlight.
That's what Mr. Paul's writing every day. It's just too long.
So, what does this say? Find the image of each letter after transformation. Now, one of the things to talk about right now, before we go anywhere else in this, the one on the right happens first. So if you have some reflection composed with some translation of some object, this happens first, which then means that this happens secondly. A lot of us are having some struggles on this, especially some of the masteries that I graded. So the thing we have to realize is the reflection on line L happens first. So if we reflect on line L, we have to think of like if I folded my paper on that line and that T was like wet ink and I stuck it on the other side and I unfolded it, what would it then look like? Well, if I fold right across here, everything's going to be equidistant from the line of reflection. So if that's closer, then the base of it will be closer. If this is further away, the top of it will be further away. So I see that this is at a 45-degree angle, so it's not going to, like, when I reflect across a line at a, to make this easier, when I reflect across the line, let's say at a 90-degree line, that X would just flip, and what was left is now right. What was right is now left. It's completely flipped over. We don't really want to say 180 degrees, but kind of, I mean, it's going the whole way. It's not like it turned sideways, right? It's still standing. But now I don't have a vertical line. I have a 45-degree line. So now when this reflects, it's going to reflect in a manner that makes my T lay down sideways. So my T will come out here and look something like this, although I kind of a poor drawing here. Does that make sense why that would happen across the line L?
Yeah, I got confused because I thought it meant you had to reflect it 45 degrees.
No, so the line's at 45, so actually, and this is dangerous until you do a decent amount of practice, that reflection is going to somewhat mimic what a 90-degree rotation would be, but it doesn't, because if I labeled these points, let's say I made these A, B, C, well this is C prime, but A prime has flipped way over here, and B prime is right there, because we reflected instead of rotating. If we rotated, this would be A prime, and this would be B prime, which is where some of you are having struggles, like the masteries that I've graded. You got to be careful to check your prime points. It might look right, but if your prime points aren't right, it's not right. So then we would want to reflect across line M, and since it's a straight line and things are perpendicular with it, it will stay like that. Crappy drawing. Sorry, this looks like somehow it got bigger. But then A double prime would be right there, B double prime would be right there, and C double prime would be right there.
Thank you.
You are welcome. Questions? So I guess those two are covered. Anything else? Questions on demand? That one came from chapter 8, but I'll take anything. Yeah, guys.
9.3,
G or K? Question 32. Crap, I keep clicking on the wrong thing. By the way, guys, if anyone, well, it doesn't really matter. I need to leave slightly before noon because I have to get over to the education center by noon. So if anyone needs to use my phone or anything, but you can hang out here until noon or whatever. In the front lobby, we've got couches and whatever, and you can hang out outside in the courtyard. But if you need to use my phone or whatever, I just have to get out of here probably by like 11:50. That's still almost 2 hours from now. So I feel like most of you guys will probably leave before then, but just to let you guys know, I have to go meet with Mr. Kazmarek and Mr. Genius. Yes, that's his real name. There's a guy in the district whose last name is Genius. Trapezoid QRST has 2 right angles. A 5-inch altitude can be drawn dividing QRST into a rectangle and an isosceles right triangle. The longer side of the rectangle measures 9 inches. What is the area of the trapezoid? So now trapezoid can mean a lot of different things. So if I start to reason through this, I'm just going to highlight what seems important. So I'm going to change colors based on each different piece that I think is important. So trapezoid, and I hate when it does that. 2 right angles. Okay, sweet. Not all trapezoids have right angles. I'm going to switch colors. 5-inch altitude. That divides into, I'm actually going to switch colors there. Right triangle, isosceles, and rectangle. So I can start to kind of in my brain think, well, we've got a piece of this that's going to be rectangular. We've got a piece of it that has to be right triangular. But, isosceles right triangle. Well, that wouldn't be isosceles right. The only way to make an isosceles right triangle is to have what 2 sides be equal? Can a leg be equal to the hypotenuse? Your hypotenuse is the longest side, so that wouldn't work. So my isosceles right would have to have 2 legs that are equal, so we're going to end up with like a 45-45. So that's not quite perfect, but we know that this will be equal to that, which means that this will be the same as that, potentially, if that's where they meet up. This is just what's going on in my head as I read through this. So then, another new color. Longer side of the rectangle measures 9 inches. And I'll highlight below that because it's kind of a dark highlighter. So now we know that this, if we set up the rectangle like that, is 9 inches. And the altitude that split the rectangle and the triangle, bless you, is 5 inches. So that altitude means it drops to the base perpendicular. So not that it literally has to be standing vertical because your shape could totally be turned, but it goes perpendicular to the base. So that would probably mean that that's 5 inches, which would mean that this is 5 inches and this would have to be 5 inches. And if all of this makes sense and comes together, what I end up with right angle, there's my 2 right angles, 5-inch altitude, 5-inch altitude, that divides into rectangle and isosceles right triangle. So, okay, these are equal. That's isosceles right now, as long as this is right. So now I've got my isosceles right. Longer side of the rectangle measures 9. Sweet. Did I meet all the criteria? Yeah, that's it. So then if I want to add up my base down here, I just add my 5 with my 9, and I get that that's 14. I would know that this is 5, and I don't really need the hypotenuse. I could figure it out, but I don't need it. Questions? For what it's worth, in the 45, 45, 90 right triangle, this is a special right triangle because it's isosceles, which means this angle will equal this angle. The hypotenuse, anyone know the relationship with the 5? When you have 2 congruent angles, the relationship that happens between the short leg, or the legs, and the hypotenuse is 5 radical 2. So I want to pull up my rules just to double check, because I bounce all over the different math topics. But in my brain, what I remember from when I did this was when two angles are the same, we use the radical 2. When we use the 30, 60, 90, we use the radical 3. So I'm going to check just to verify my special right triangle rules. And there's my 45, 45. There is my x radical 2. So I don't need the hypotenuse there, but if you did, it would only be 5 radical 2. Other preguntas. Cassie, does that help you? You're welcome. Break it apart. Always, especially with those long, written out, like typed out problems, or like word problems, I guess we say. That's not really a word problem. But just like chunk it. Chunk it into like, what can I do to start? What can I do next? What can I do? And then if I goof up, I just go back and take a step away. Other practice problems. Otherwise, we can just stop and I can work one-on-one with you guys. Want nothing from back in chapter 5 or 6 or 7. Alright. I will just stop the video and then we can work one-on-one. Anybody that needs help, if you need tests or whatever else, I'm here for you.